Welcome back, all you pre-AP scholars out there in Radio Land. Here we are on page 695, the first of two trig chapters in our book. These are chapters 12 and 13. You probably wonder why we skipped chapter 11. Well, it's statistics, so we don't do that in this class. But we are going to do the 6 trig functions. Well, you more than likely remember from your geometry class, Sohcahtoa right here, this stands for sine of opposite over hypotenuse. Hypotenuse. Okay, so that sine is opposite over hypotenuse. You might say it like this. You could learn it this way. You may have learned it that way. So whenever you say sine opposite hypotenuse. So say it out loud. The sine of angle X is opposite over hypotenuse. This is for cosine. It's adjacent over hypotenuse. And so this one would be the cosine of an angle is adjacent over the hypotenuse. Well, these angles are all acute angles and right triangles is what they are. And then this one's for tangent. The tangent is the opposite over the adjacent. That one's sort of crooked right there. The tangent of angle X is opposite over adjacent. So my suggestion is use Sohcahtoa on anytime you get a right triangle. Okay, and then the task is going to be to write the 6 trig functions. Well, sine, cosine, and tangent are only 3 of them. You may not have ever seen the other 3. Okay, so what you want to do every time is write this opposite over hypotenuse. Cosine is that's cosine is adjacent over hypotenuse, and tangent is toa. That's the opposite, O for opposite, A for adjacent. And then we got sine, cosine, and tangent. Okay, and then these all have reciprocals. And so they're called the reciprocal functions, and they have names. So this one is called cosecant, this one is called secant, and this one is called cotangent. So we're going to abbreviate cosecant CSC, and we're going to flip the opposite and the hypotenuse over here to hypotenuse over opposite. This one is secant. SEC stands for secant. It doesn't stand for the Security and Exchange Commission. There's your joke of the day right there. This one's hypotenuse over adjacent, and cotangent is cot, which sounds like something you'd sleep on, which makes me tired, and this one is adjacent, it's funny right there, over hypotenuse. Okay, so they're going to give give us triangles, and they're going to want us to write all 6. So when they say write 6, they want sine, cosine, tangent, cosecant, secant, and cotangent. We always want to write them in this order. Okay, so here's your first example problem, or number 1. On number 1, they're going to give you a right triangle. It's going to look like this. 8, 6, and theta. Okay, they're going to put theta up here. They're going to do 8 over there and 6 over there. Well, theta is a Greek letter. You're going to see it a lot. Since the Greeks came up with a bunch of this, they like to use Greek letters: theta, beta, alpha, gamma, rho, alpha, omega, whatever. But they usually use theta and beta the most. If you ever see a goofy looking B like that, which has the stem down here longer, that one is beta. Of course, we're not using it on this one, but you might see it. And then they're going to want the 6 trig functions, okay? So I'm going to do Sohcahtoa over here. That's going to be sine of theta, cosine of theta, tangent of theta, and then cosecant. Once we find these, we're just going to flip the fraction. Secant of theta, cotangent of theta. There's my 6 answers that they want. Of course, I need all 3 sides of this triangle up here. Well, notice this side over here is opposite angle theta. This side is adjacent to theta. So sometimes we get asked, well, I don't know which side is the opposite. We'll look as far away from that acute angle as you can look, and you see 8. Okay, we need the Pythagorean Theorem to find this, so I would need to do 6 squared plus 8 squared equals c squared. This is 36, 64 is c squared, 100 is c squared, square root of both sides. C is 10. So there we go on that one. And so the opposite is 8, the hypotenuse is 10. These are both even, please reduce it. Flip that, and you got the cosecant. Cosine is adjacent over hypotenuse. Flip the 5/3. This one is opposite over adjacent. This one is 4/3. Flip this to 3/4. And we're done. So there's an explanation of how to find the 6 in one example. And we're at about 8 minutes. So let's see. I can't go over 15 or they start freaking out at your local neighborhood YouTube. But I think I'm going to sign off with this anyway and add a second video for number 2, which will be forthcoming. So over and out at about 9 minutes. Y'all are doing great. Just hang in there. This stuff is pretty easy right here, and over and out.